Hello everyone, I am going to start new course on Gset examination in the subject of physics. So in Gset exam, there are total 9 subjects in physics. Uh, the first one is mathematical physics. Second one is quantum mechanics. Third one is classical mechanics. Fourth one thermodynamics and statistical mechanics. Fifth one is electronics. Sixth सॉलिड स्टेट फिजिक्स या फिर कंडेंस्ड मैटर फिजिक्स. The next seventh is atomic and molecular physics. Then eighth one is nuclear and particle physics. Then electromagnetic theory or electrodynamics. Average 10 to 12 questions will be asked from each subject. Like if we are talking about mathematical physics, 12 to 14 questions will be there. Then in quantum mechanics, also about 10 to 13 questions. In classical mechanics, 12 to 14 questions. And in other all subjects, around average 10 to 12 questions will be there. And also I will discuss about the paper solutions before the exam. I think the exam will be on December. So I will take lectures on paper solutions in the month of November. Okay. Now I am going to discuss our first subject, which is atomic and molecular physics. Now I am going to start a new subject, which is atomic and molecular physics. Atomic and molecular physics. Generally, this subject has two parts. The first is atomic physics, and the second one is molecular physics. Molecular physics. Okay. So now I am discussing about molecular physics. In molecular physics, let me know that which topic I am going to cover. So in this lecture, I will only discuss about the syllabus. So the syllabus. So firstly, I will discuss about the fundamentals. In fundamentals, I will clear the concept of atoms, like what is the difference between atoms and molecules. Then I will talk about absorption, then emission, and also about spectroscopic. Then I am going to discuss the main topic, which is rotational spectroscopy. Rotational spectroscopy. It is also called microwave spectroscopy. So in this topic, I will discuss about types of molecules which showing the rotational spectra. Then second one is theory of rotational spectra. Then third one is like population of different rotational levels. Okay. Now I'm going to discuss about the classical explanation of rotational spectroscopy. So suppose I have a molecule which is HCl, like one is H plus and Cl minus. Okay. So if I shine a photon or if I shine a electromagnetic radiation, EM radiation with frequency mu, या फिर इसकी frequency है 10⁻⁹ okay. If I'm going to simplify this situation, let's assume I have two plates, or you can assume capacitor plates. So between two plates, I attached AFO, okay, and also in I placed HCl, okay, like H plus and Cl minus, and here is the bond H plus and Cl minus, okay. And whenever I shine a photon on this, now try to understand that what am I saying. Like our EM wave is this kind of wave, okay. So it has positive cycle, negative cycle, then positive cycle, okay. So in positive cycle, the plus part is going to here and the minus part is going to here. So now here is the plus and here, and the molecule has the plus sign. So what will going to happen? It will repel, okay. So plus is going to downward and the minus one is going to upward, okay. So one rotation is completed. Now the situation of the molecule is this kind, like minus part is going to upward and the positive part is going to downward, okay. So now look at the EM wave after the positive cycle. Now it is going to apply the negative cycle, then the negative term is going to here and the positive is going to here. So again it is going to rotating, okay, and positive sign is going to upward. So it is going to keep rotating. In incident, I have applied 10⁹ Hertz frequency. If I incident 10⁹ Hertz of frequency, then this molecule is going to rotate 10⁹ times per second. ओके एक सेकेंड के अंदर वो 10⁹ टाइम्स वो रोटेट करेगा और हर एक रोटेशन पे वो रेडिएशन एमिट करेगा, ओके। तो ये जो रेडिएशन हम स्पेक्ट्रोमीटर के थ्रू ऑब्जर्व करेंगे. आफ्टर ऑब्जर्वेशन वी विल गेट स्पेक्ट्रा. That's why it is called rotational spectroscopy. Okay. And this 10⁹ Hertz frequency is nothing but actually in the region of 10⁹ Hertz frequency is in the region of microwave. That's why it's also called microwave spectroscopy. Okay. So now, the third topic which we are going to discuss, vibrational spectroscopy. Vibrational spectroscopy. तो पहले हमने डिस्कस किया था कि अगर मैं 10⁹ हर्ट्ज की फ्रीक्वेंसी इंसिडेंट करवाऊँ तो क्या होता है. तो मोलिक्यूल इज गोइंग टू rotating, right? Now if I'm going to shine a photon which has frequency of 10⁻12 hertz, then molecule is not going to rotating. Okay. Same example I'm going to now. What will going to happen? Suppose the molecule is non-rigid, means the bond is like a spring. Like the plus one is here the minus one is here. Okay, and the bond is going like a spring. Okay, here 10 raised to 12 hertz is much more than 10 raised to 9 hertz. So if I'm going to shine a photon, okay, up to this frequency, if I shine a photon up to 10 raised to 12 hertz of frequency, then the molecule is not capable to do a rotation, but it feels a force. Like suppose I apply the positive cycle, so plus here and minus one is here. So now what going to happen? So positive is going to repel and negative is going to repel. So it is now going to compress. Okay, molecule क्या होगा? Compress हो जाएगा. Okay, in the second cycle it is going to phase change. Then we have here minus and here plus. So now it is going to attraction plus minus minus plus. Okay, so plus here, then minus here. Okay, and also it radiates and also it emits radiation which we are going to observe through the spectrometer. Okay, so due to vibration we are going to observe the spectra which is called vibrational spectroscopy. Okay, and the range of this and the 10 raised to 12 hertz of range is nothing but IR range, infrared range. Okay, so further in our syllabus I will discuss about the types of molecules. I'm going to discuss about types of molecules which are going to show the vibrational spectroscopy. Then second one is quantum theory of vibrational spectroscopy. So in this quantum theory, I will discuss three topics, which the first one is fine spectra of vibration. Then second one is P and R branches. P and R branches. Then third one is Q branch. Okay, so after that I'm going to discuss about electronic spectroscopy. Okay, in the range of this spectroscopy will be visible and ultraviolet. Then after that Raman spectroscopy. Okay, the range will be infrared, visible and UV. Okay, so in Raman spectroscopy discuss the brief introduction about. Suppose I have a sample. Okay, I have this kind of sample and I am shining a photon or a EM radiation of the energy h nu naught. Okay, I apply a nu naught of frequency on the sample. Okay, then we are going to observe three kind of photons. Okay, with different frequencies, like the frequency of the emitted photon will be less than the frequency of incident radiation. Okay. And the second one, the output frequency is as equal to input frequency. And the third one we are getting, which one is that the output frequency is greater than that of input frequency. Okay, so जो कम फ्रीक्वेंसी वाला फोटोन है उसको हम बोलेंगे स्टॉक लाइन. फिर बराबर की जो फ्रीक्वेंसी है उसको हम बोलेंगे रेली लाइन, एंड जिसकी फ्रीक्वेंसी आउटपुट में ज़्यादा है उसे हम बोलेंगे एंटी स्टॉक लाइन, एंटी स्टॉक लाइन. Okay, so in Raman spectroscopy we are also going to discuss the classical theory. We will discuss classical theory as well as quantum theory. पूरे फिजिक्स में जहाँ पर भी क्लासिकल फिजिक्स या फिर क्लासिकल थियोरी फेल हो जाती है वहाँ पे उसको सॉल्व करने की बारी आती है क्वांटम फिजिक्स की या फिर क्वांटम थियोरी की. ओके, देन उसके बाद हमारा नेक्स्ट टॉपिक होगा वो है न्यूक्लियर मैग्नेटिक रेजोनेंस. NMR. ठीक है, उसके बाद मैं डिस्कस करूँगा इलेक्ट्रॉन स्पिन रेजोनेंस के बारे में. ओके, देन आवर लास्ट टॉपिक विल बी लेज़र. Which is light amplification and stimulation emission by radiation. Okay, in laser we are going to discuss the topics like theory of laser, then rate equations, then types of laser like helium neon laser, ruby laser. Okay, then last one will be properties of laser. I also requesting you all to focus that what am I saying. I assure you will get better idea to clear the concept. So from next lecture I will start the fundamentals. So okay, then मिलते हैं नेक्स्ट लेक्चर में. जय हिंद.